Hello everyone, welcome to my channel Concept in Chemistry. In this video, I will discuss about the mole concept. This is the part 2. Part 1 I have given in the first video. So, in this part, we'll study the Avogadro hypothesis. First, we have to know what is Avogadro number. Avogadro number. It is represented as NA, capital N subscript capital A. It is just a number and it is unit less, dimensional less, constant value. Its value is 6.023 into 10 to the power 23. Okay. Now the relations. What are the relations of Na? This Avogadro number, relations of Avogadro number with gram atom, gram molecule or gram ion. So, the relations are as follows. Number of atoms in 1 gram atom is equals to 6.023 into 10 to the power 23. So, this is the number of atoms present in 1 gram atom of an element. Number of atoms in 1 gram molecule of a molecule is atoms is 6.023 into 10 to the power 23 molecules. That means in 1 gram molecule there are 6.023 into 10 to the power 23 number of molecules. Number of ions, number of molecules, this should be number of molecules. Number of ions in 1 gram ion, this is also equals to the same constant value, 6.023 into 10 to the power 23 number of ions. Some examples are number of nitrogen atoms in 1 gram atom nitrogen is equal to 6.023 into 10 to the power 23. That means 1 gram atom nitrogen. 1 gram atom nitrogen means 14 gram nitrogen. That means in 14 gram nitrogen there are 6.023 into 10 to the power 23 number of nitrogen atoms. Or we can say number of CO2 molecules in 1 gram molecule CO2. 1 gram molecule CO2 means its molecular weight, that means 44 gram. It also has 6.023 into 10 to the power 23 number of CO2 molecules. So whatever it is atom or molecule, if it is 1 gram atom or 1 gram molecule of the molecule, then the number of atoms or number of molecules are same in that system. What is the application of Avogadro number? Now I will discuss about the application of Avogadro number. It can be used to calculate actual weight. It can be used to calculate the actual weight of an atom. As for example, 6.023 into 10 to the power 20. As for example, 6.023 into 10 to the power 23 number of nitrogen atom has weight is equal to 14 gram, because in 1 gram atom of nitrogen there are 6.023 into 10 to the power 23 numbers of nitrogen atom. 1 gram atom, so I can write here 6.023 into 10 to the power 23 number of atom equals to 1 gram atom nitrogen. We know this. And 1 gram atom nitrogen, we know it is equals to 14 gram nitrogen. So 1 nitrogen atom equals to 14 divided by 6.023 into 10 to the power 23, that is equal to 14 into 1.6603 into 10 to the power minus 24 gram. That means the weight of one nitrogen atom is 16 into 1.6603 into 10 to the power 24, or we can say it is equal to 14 EMU. So using Avogadro number, we can calculate the actual weight of an atom. Second, calculation of actual weight of a molecule. Similarly, 6.023 into 10 to the power 23 number of CO2 molecules. Let's take number of CO2 molecules equals to 1 gram molecule of CO2, and 1 gram molecule of CO2 we know it is equal to gram molecular weight of CO2, which is 44 gram. So it is 44 gram. So one CO2 molecule has 44 by 6.023 into 10 to the power 23 gram weight. It is also equals to 6603 into 10 to the power minus 24 gram, or 44 AMU, atomic mass unit. So this is the actual weight of carbon dioxide molecule. So in this way we can calculate the actual weight of an atom or an actual weight of a molecule. Now come to mole concept. According to mole concept, we know 1 mole anything. It can be atom, it can be molecule, it can be ion. 1 mole anything has 6.03 number into 10 to the power 23 numbers of particles. Okay, as for example, 1 mole is equal to 1 mole of an atom equals to 6.023 into 10 to the power 23 number of atoms. So in a atomic substance, if there is 6.023 into 10 to the power 23 number of atoms, then the total atomic substance is called 1 mole of atom. Or we can say 1 mole of a molecule is equal to 6.023 into 10 to the power 23 number of molecules. It is true for an ion also, number of ions. So basically it is a counting concept. Basically we know 1 dozen banana is equal to 12 banana. In the same way, 1 mole atom has 6.023 into 10 to the power 23 number of atoms, or Avogadro number of atoms. 1 mole molecule has Avogadro number of molecules, and 1 mole ion has Avogadro number of ions. Again, the relation of mole with the gram atom or gram molecule or gram ion is as follows: 1 mole is equal to 1 mole atom is equal to 1 gram atom is equal to Avogadro number of atoms, 6.023 into 10 to the power 23 number of atoms. So 1 gram atom is called 1 mole. Similarly, for a molecule, 1 mole molecule is equals to 1 gram molecule. equals to Avogadro number of molecules. So these are the relation of gram atom with mole and gram molecule with mole. So the mole concept is such that 1 mole of an atom is equal to 1 gram atom is equal to Avogadro number of atoms. It has Avogadro number of atoms, and 1 mole of a molecule is equal to 1 gram molecule of the molecular substance, and it has Avogadro number of molecules. As for example, or for ion, we can also say 1 mole ion is equal to 1 gram ion is equal to Avogadro number of ions. Some examples are 1 mole nitrogen atom is equal to 1 gram atom nitrogen is equal to 14 gram nitrogen, and it has 6.023 into 10 to the power 23 number of nitrogen atoms. This is for atomic system. For molecular system, 1 mole CO2 molecule, it contains 1 gram molecule CO2 equals to 44 gram CO2, and it has the same 6.023 into 10 to the power 23 number of CO2 molecules, right? Again, here 1 millimole is equal to 10 to the minus 3 mole. This relation is used for various mathematical calculations. Now come to molar volume. What is molar volume? This is the volume of a gas. This is the volume of 1 mole gas at a particular temperature and pressure. This is the volume of 1 mole gas at a particular T and P. Now, if we fix the temperature at 25 degrees centigrade and pressure at 1 atmosphere, this condition is called normal temperature and pressure, NTP. Then the value of molar volume becomes equals to 22.4 liter. That means 1 mole at NTP, 1 mole gas has 22.4 liter volume. As for example, at NTP, 1 mole CO2 gas is equal to 22.4 liter CO2, and 1 mole N2 gas has 22.4 liter. That means the volume is same if the mole number is same. Now, what is Avogadro hypothesis? What is Avogadro hypothesis? It states that equal volume of all gases at the same temperature and pressure has same number of gas molecules. That means let's say a carbon dioxide gas whose volume is V1, let's take it V, and a nitrogen gas whose volume is V. So these two different gas has same volume at same T and P. Then according to Avogadro hypothesis, we can say the number of CO2 molecules and number of N2 gas molecules in this condition is same, and it is same. Number of molecules is same. Okay, now let's take an example. The example is at NTP, volume of 1 mole N2 gas is 22.4 liter, and volume of 1 mole CO2 gas is the same 22.4 liter according to molar volume. Both nitrogen and carbon dioxide has same volume at same temperature and pressure. That means temperature is 25 degrees centigrade and pressure is 1 atmosphere, and in this situation both the molecules have same number, both the gases has same number of gas molecules, and that is equal to 6.023 into 10 to the power 23, and this is because one mole nitrogen has Avogadro number of nitrogen molecules, and 1 mole carbon dioxide has Avogadro number of carbon dioxide molecules. That's why for at NTP for one mole nitrogen gas contain 1 mole nitrogen gas has 22.4 liter volume, and 1 mole carbon dioxide has 22.4 liter volume. And both N2 and CO2 contain same number of gas molecules, and this is the Avogadro hypothesis, that at same volume and same temperature and same pressure all the gas molecules have same number of, all the gases have same number of gas molecules. If the temperature and pressure kept at normal condition, that means at 25 degrees centigrade and 1 atmosphere pressure, and the gaseous substances are taken as 1 mole, then this number becomes equals to the Avogadro number. Now this is I am going to show a relation map which is very important, very important to remember. 1 mole, it is for a molecule, for a molecular substance, it is equals to 1 gram molecule. For an atomic system or atomic substance, it is equals to 1 gram atom. For an ionic system, it is 1 gram ion, and for a gaseous system at normal temperature and pressure, the volume becomes volume of gas at NTP, it be 1 mole of any gas, it is becomes equal to 22.4 liter, and for and the relation of mole with numbers is 1 mole is equal to 6.023 and to 10 to the power 23. This is Avogadro number. The relation of mole with Avogadro number is 1 mole is equal to 6.023 into 10 to the power 23 numbers of, it may be atom or it may be molecule or it may be ions. Okay. Now how to calculate mole number. That means what is mole number? It is represented as small n. Mole number is equal to weight of the substance or weight of the molecule by molecular weight of the molecule. As for example, let's take an example that H2SO. It has molecular weight is equal to 2 into 1 plus 32 into 16 into 4, that is equal to 98, and let's say for 49 gram H2SO4 mole number becomes equal to 49 by 98, that is 2. For 196 gram of H2SO4 mole number is equal to 196 by 98, that is equal to, it is equal to 1 by 2 and this is equal to 2. So in that way we can calculate the mole number of any substance or of any molecule, that is mole number is equal to the weight of the substance by molecular weight of the substance. Okay, here are some question and answers given in my written note. Please go through that to gain the better knowledge of this mole concept. And this is the handwritten note, and I uploaded it in the Google Drive and my Facebook page. Please go through that. That's it. Thank you.